Okay, so you heard me use this word probably in Unit 1, but you may not remember me using it. The reason that we could not evaluate this limit right off the bat is because it was indeterminate. Okay? When we plug in -1, what do we get for our numerator? 0. What do we get for our denominator? 0. Okay, 0 over 0. Is that 1? Is that 0? There's no way of knowing. Okay, we can't take 0 divided by 0. Okay, that's what we call an indeterminate form. However, L'Hopital came up with a method that if we have an indeterminate form for a limit, we can apply some differentiation to help us out. Okay. So, if we have a limit that gives us either 0 over 0 or infinity over infinity, this is what we can do. Go ahead and write it down and then we'll talk through it more. It was one of those things like who published it first. What is it?
Mr. Marsh. I think you guys should.
You've already talked about it with Mr. Marsh.
Yeah, yesterday. First, Bernoulli had some physics. Yeah, not.
Oh, okay.
Bernoulli's. It's all over the place.
Okay. So first of all, if we have a limit 0 over 0, infinity over infinity, those are indeterminate forms. It's 0 over 0, 1 because we're dividing the same number by itself. It's 0 over 0, 0 because 0 divided by anything is 0. Right? You know, we're dividing by 0, so that's not possible. Okay? We cannot determine what 0 over 0 is. Same thing with infinity over infinity. Okay? Infinity over infinity is not 1. All right? Now, if we have any form of 0 over 0, infinity over infinity, positive or negative, okay, then what we can do is we can take the derivative of our numerator and the derivative of our denominator and then evaluate the limit from there. Okay. It is not a quotient rule. Okay. It does have to be a fraction in order to use L'Hopital's rule, but we take the derivative of the numerator and the derivative of the denominator, so it's actually nicer. Now, these are the indeterminate forms that we will work with the most in this class, but there are actually 7 indeterminate forms. These are the other ones. 0 to the 0, 1 to the infinity, infinity minus infinity, 0 times infinity, and infinity to the 0. Those are all indeterminate forms. Okay? If we have limits of these indeterminate forms, we can rewrite them so that they can become 0 over 0 or infinity over infinity. So we can apply L'Hopital's rule. Okay? We will look at one of those cases today, but we're mainly going to focus on the 0 over 0 and infinity over infinity. All right, so our first example. If we recall back from Unit 1, anytime we evaluate a limit, the first thing we need to try is what? Okay, direct substitution. Plug it in. What's e to the 0? Minus 1 over 0. Okay, that's an indeterminate form, which means we can use L'Hopital's rule. Okay? So what we're going to do is we're going to rewrite this as the limit as x approaches 0. We're going to take the derivative of the numerator. Abram, what's the derivative of our numerator?
3xe. E to the 3x?
Okay, Abram. I've asked Abram to do this. What do you think it is, Abram?
I thought it was 3x e to the 3x minus 1. I don't know. Something like that.
Something like this?
Yeah.
Okay. And Cole obviously disagrees with you. He's being very vocal about that. Cole, what do you think it is?
Well, I thought you just copy paste and then give the derivative of both strings.
Oh, yeah.
Abram, are you changing your mind?
Mine is not right, but I don't know.
Okay, so Abram decided he is not right. Can anybody confirm Cole?
Yeah.
What does that mean?
Copy paste times the derivative of the inside. Yes, it is 3e to the 3x. Okay. Then we're going to divide by the derivative of our denominator. Larry, what's the derivative of our denominator? 1. Now that we've applied L'Hopital's rule, now we can try direct substitution. When we plug in 0, we get 3e to the 0 over 1. What does that reduce down to? So our limit is 3. Okay. Questions? As long as it's 0 over 0, or infinity over infinity, positive or negative, we can take the derivative of the numerator, derivative of the denominator separately, and then plug in. Let's try another one. As x goes to infinity, what happens to the natural log of x? As x goes to infinity, what happens to the natural log of x? Say it louder, Logan. Please remember that this is what the natural log graph looks like. As we go to infinity, the natural log continues to rise. Okay? 2 radical x. As we go to infinity, what happens with that one? It also goes to infinity. Remember, radical x is our shooting star, right? Okay, so we have infinity over infinity, which means we need to use L'Hopital's rule. Okay? Okay? Gina, what is the derivative of natural log of x? Somebody help her out. It's you.
Over X.
1 over x. These are good things to refresh on, right? All right, and then 2 radical x. Sammy, what's that derivative?
Wouldn't it just be, since x is to the 1/5, would just be x to the negative 1/5?
Is that correct? X to the negative 1/2. Because what she did in her head is we have the 2 times the 1/2 power, and so those are going to cancel out. Okay, so if you need that there, that is it. But it is x to the negative 1/2. Okay, so now we should probably rewrite this and simplify our fraction as much as we can. Okay, so what we have is the limit as x approaches infinity of 1 over x divided by 1 over x to the negative, positive 1/2, right? What does that reduce to? Okay, and then what does that reduce down to? Okay, Cole, I like where you're going with that.
Yeah.
Will you say that louder?
Yeah, I wrote it as x to the negative 1 over x diagonal.
So we have, when we squish those together, we have x to the what? Negative 1/2, right? Okay, I like that better. Thanks, Cole. So now what we are looking at is the limit as x approaches infinity of 1 over x to the 1/2. Say that louder.
Let's just equal to 0.
Okay, x to the 1/2 as we go to infinity. That's square root of x, that's that shooting star. That's going to go to infinity. 1 divided by infinity is going to give us 0. Questions before the third example?
Whenever you're dividing by infinity, it's always negative 0.
As long as the number at top is not infinity or 0. All right, next one. All right, as we go towards negative infinity, x squared is going to where? Infinity. X squared looks like this, right? Doesn't matter which side we're looking at, this goes to infinity. E to the negative x, as we go towards negative infinity, where does that go? E to the negative x, exponential decay. Towards negative infinity, it goes towards positive infinity. All right, we have an indeterminate form, which means we must use L'Hopital's rule. Okay, I do want to see the indeterminate form that you have so that I know that you are using L'Hopital's rule. Okay, I want to see you actually write this down. All right, so the derivative of our numerator is what, Josh? And the derivative of our denominator is what, Josie?
Would it be negative e? Actually, it's negative x.
Yes. Okay. So now let's evaluate our limit. Towards negative infinity, what's happening to 2x? Going to negative infinity. And negative e to the negative x. Where's that going? This is e to the negative x. What does the negative do? Flips it. So towards negative infinity, what's happening? We're going toward negative infinity. Okay. Common. We used L'Hopital's rule. It didn't work. It is okay to use L'Hopital's rule more than once. If you have an indeterminate form after you've used L'Hopital's rule once, just use it again. As long as you have an indeterminate form, you can use L'Hopital's rule. So, we have to do this one more time. We have an indeterminate form. Okay? The derivative of 2x. Everybody.
2.
Okay. That was like just Cole and one female voice. What is the derivative of... That is not appropriate in my classroom.
What is
Still comment.
it?
Yeah. No. No. Apologize right now.
Sorry.
Thank you. What is the derivative of 2x?
2.
Someone enthusiasm. Okay. The derivative of our denominator. Jake, what is it? E to the negative x. Now what happens when we plug in negative infinity? Okay, we have 2 over infinity, which goes to 0. Hold on.
I can't see it.
I'm pulling an audible here. What? What did you say, William? It is December 1st.
No, it's not November 31st. That's what I
It
thought.
is December 1st.
Dude, really? It's Christmas time. I'm pretty sure it's the 31st.
Okay. What happens when we plug 6 into this one?
You get 1 over 0.
Is 1 over 0 indeterminate? No, it is not. Okay, we cannot use L'Hopital's rule on this one. What is happening at x equals 6? There's an asymptote. And what's happening is from the right side, our graph is rising. From the left side, our graph is falling. So this limit doesn't exist. Okay, this is one of those where we would have to look at the limit from the right and the limit from the left to determine that the limit doesn't exist. If we plug in numbers to the right of 6, we're going to get positive numbers that increase. If we plug in numbers to the left of 6, we're going to get negative numbers that decrease. Make sure you check to see that it is indeterminate before just zooming on to L'Hopital's rule. Write this one down. There is not a product rule for L'Hopital. Okay? Is this even indeterminate? That's what we have to determine first. If I give you a limit, you can't just use L'Hopital's rule like it's nothing. Okay? You have to make sure that it's indeterminate. So, e to the negative x towards infinity is what? Zero. E to the negative x. Exponential decay. Towards infinity, we're approaching 0.
Okay, so that's e to the negative x, and then negative e to the x is upside down. And then what about e to the
Negative e to
Drawing.
And if
Okay.
there's a negative in front, they flip. All right, square root of x towards infinity. Positive infinity. 0 times infinity, is that indeterminate?
Yes.
It sure is. Okay? Why is this indeterminate? We know that 0 times anything is 0, but then we also say infinity times anything is infinity. Okay, so we don't know which one to use. It's indeterminate. All right? Now, we cannot use L'Hopital's rule unless it is written as a fraction. Is there a way to write this as a fraction?
So 1/2 over e to the x.
Since e is being raised to the negative x power, we can move it to the denominator as a positive power. And now we have infinity over infinity. So now we can apply L'Hopital's rule to this problem. Aaron, what's the derivative of our numerator?
1/2 x to the negative 1.
And we're going to try this again. Whole class, what's the derivative of e to the x? Okay, so what we really have is 1 over 2 square root of x e to the x. As we go towards infinity, that denominator is going to go where? Our denominator is going towards infinity, right? This is going to get bigger and bigger and bigger, which means 1 over that is 0. Okay? Now, some of you are going to start to wonder, well, are all of these answers going to be 0? No, they are not all going to be 0. Okay? We've seen a couple up here in our examples that have been 0. We got to go forward. One more example, and then I'll give you one to do on your own. Are you ready? What's the limit as x approaches infinity of x. Infinity. Now, if we look at sine of 1 over x, or sine of 1 over infinity. 1 over infinity we say is 0. What's the sine of 0? We once again have an indeterminate form that is not a fraction. How, brainstorm with your pod, how can we take x times sine of 1 over x and create a fraction of it? 1, 2, 3, go. All right, pod 1, do you have an idea? Pod 1, that's like Larry and Josie and Jennifer and Michael. Do you have an idea?
I feel that when we came up with two different things, but my idea was that x would be like 1 over x to the negative 1 to the stuff to the negative 1.
Okay, so you're saying that I can bring x the first as x to the negative first in the denominator?
And keep signing.
Is that legitimate?
Or make the fraction just x to the negative 1. Or no?
You mean the 1 over x? You can do that. Like sine of 1 over, or sine of x to the negative 1. But it has to stay with the sign. Okay, you can't move the sign and, like, you can't take the sign and put it in the denominator and it's changed what's inside. Like, I know a lot of you are trying to manipulate sign. I heard that in a lot of your conversations. We can't change what's inside even if it moves down to the denominator. So we're gonna have to leave it like that. The only other option, did anybody talk about changing sine to cosecant? Okay, you could write that as x over cosecant of 1 over x, and that would be fine. Okay. So now we have 0 over 0. Okay. The derivative of sine is positive cosine. And the derivative of what's inside, okay, inside we basically have x to the negative first. So the derivative of that is, yes, negative x to the negative 2. Conveniently, our denominator, its derivative is negative x to the negative 2. So we have the limit as x approaches infinity of the cosine of 1 over x. Now, what happens as x goes to infinity of 1 over x? We have 0. Therefore, what's the cosine of 0? 1. Very good. Okay. I'm going to give each of you a problem that I would like you to complete. Each of you at your table have a different problem. You can complete it on the card or in your notes, I don't care.